Hi, Year 11. This is our third lesson for the topic of functions. In this lesson, we're going to learn about linear relationships. So far, we have covered types of relations, vertical and horizontal line tests, functions, and function notation. Then we looked at the features of a graph, intercepts, asymptotes, and turning points, domain and range, and odd and even functions. Let's begin with vertical and horizontal lines, which only have one variable, either x or y. And this is because that variable is fixed at a particular coordinate. So suppose we want to graph the lines y equals 2, y equals 4, and y equals -1. These are going to be horizontal lines. The y value is fixed at 4. It's always equal to 4. Here, y is always equal to 2. And here, y is always equal to -1. Now these lines all have a gradient of 0. Now let's graph the lines x equals 1, x equals 0, and x equals -3. These are vertical lines. In this case, x is always equal to -3. Here, x is always equal to 0. This is the y-axis. And here, x is always equal to 1. And the gradient of vertical lines is undefined. It approaches infinity. Now, gradient is a measure of steepness. It's the rate at which the height changes as we move from left to right. And you will recall that we use the relationship rise over run, and that the symbol given for gradient is m. Gradient uses the following scale. Remember I said that vertical lines have an infinite gradient. Horizontal lines have a gradient of 0. These are all positive gradients, so they're going upwards as we go from left to right, and they increase in number the steeper they get. And these are all negative gradients. They go downhill as we go from left to right. Now we can use rise over run, but we can also create a formula. So if we want to use the coordinates x1, y1, and x2, y2, then the rise is going to be the difference in the y coordinates, y2 minus y1. And the run will be the difference in the x coordinates. So instead of rise over run, we can write y2 minus y1 all over x2 minus x1. Now this formula is not given for you on your reference sheet. Let's look at an example. Use the gradient formula to find the slope of the line between the points 3, -1 and -3, 2. So I'm going to consider this as point 1, so x1, y1, and this is point 2, x2, y2. There's my formula. I'm going to go 2, take away -1. What's your negatives? All over -3, take away 3. So let's substitute in. This is a plus here, so 2 plus 1 is 3, all over -6, and tidying that up, we get -1/2. Now we can also use trigonometry to calculate the angle of inclination, theta, for any line using m equals tan theta. The angle of inclination is the angle between the line and the positive x-axis, and it can have a value between 0 and 180 degrees. So here's our diagram from before. Now remember that m is equal to rise over run, which is also opposite on adjacent. So m is equal to tan theta. Here's an example. What is the angle of inclination of the line whose gradient is -1? So our formula is m equals tan theta, and m is -1. Now we want to solve this for theta, which means taking the tan over the other side. It's going to become inverse tan, which looks like this. If we put that into the calculator, we get -45 degrees, which isn't particularly useful. So let's just draw a quick sketch and see what's going on. We have a line whose gradient is -1, which means this angle in here is 45 degrees. Now when we put in the calculator, it's going to give us this angle here. We want this one, the angle between the line and the positive x-axis. So all we're going to do is add 180 degrees to that, and that will give us 135. Now there are two common forms for writing the equation of a line. There's gradient intercept form, y equals mx plus b, and it's quite useful because we can find the gradient, m, and the y-intercept, which will be 0b. And there's general form, and in general form we write the x's first, usually positive, plus the y's, plus the constant term is equal to 0. I said before, if a line is written in gradient-intercept form, it's really easy to find the gradient and the y-intercept from the equation. So here's an example. We have y equals 2x take away 1. Compare this with y equals mx plus b. The gradient is 2. And the y-intercept occurs at -1. So that's the point 0, -1, as we can see on the graph. Now there is a formula that we use to find the equation of a line given the gradient and a point that lies on the line. It's called the point gradient formula. Y minus y1 equals m brackets x take away x1. Now you're not given this formula on your formula sheet, but it's very similar to the gradient formula. So I suppose technically you only have to remember one formula. So here's the gradient formula. And all we do is make one of these points a variable point. Now have a look what happens when we take this x minus x1 up and over the other side. If you turn it around, we have that formula. Let's have a look how we use it. Find the equation of a line with gradient -3 through the point 1, 2. So this is x1, y1, and this is m. And all we do is substitute in. So y take away 2 is equal to -3, and then x take away 1. I'm going to expand this out and take the 2 over the other side. And that's going to leave us with y equals -3x plus 5. So I've decided to leave my answer in gradient intercept form. Here's another example, but this time we've been given 2 points and no gradient. So we're actually just going to have to find the gradient first. Here's our formula. And substituting in, I get -2 take away 2 all over 5 take away 1, which gives us -4 over 4, which is -1. Now let's substitute into our point gradient formula. We can use either of these points because they'll both lie on the line, and the gradient -1. So -1 goes in there. I'm going to use this point. 2 goes in here, and 1 goes in here. Substituting in, expand through and take your 2 over the other side. And we end up with y is equal to -x plus 3. If a point lies on a line, it is said to satisfy the equation. This means when we substitute the point in, the maths will work. Here's an example. Decide whether the point 1, -2 lies on the line y equals 2x take away 3. Now we could just substitute this point in and see, but it's actually better to do left-hand side equals than right-hand side equals. So left-hand side is equal to the y coordinate, which is -2. The right-hand side is equal to 2 lots of 1 take away 3, which is -1. They don't match. So because the left-hand side is not equal to the right-hand side, then the point does not lie on the line. Let's move on to graphing lines. The simplest way to graph lines is to use the gradient intercept form. So suppose we want to graph y equals 3x take away 1. We're going to start by finding the y-intercept, which in this case is 0, -1, and we're going to plot it. Next, we find the gradient and we write that as a fraction. The gradient is 3. To write that as a fraction is 3 over 1. So 3 represents the rise and 1 is the run. So from our y-intercept, we're going to go up 3 and across 1 and plot a point. And joining the line through those 2 points, we have our line. Now you should write the equation next to the line. Another way to graph lines is just to find any 2 points that lie on the line. So for example, we might want to graph 3x plus y is equal to 7. So when x is equal to 0, y is equal to 7. And when x is equal to 2, substituting that in, I get 6 plus 1 in this case will be 7, so y is equal to 1. We just plot the 2 points. And again, you can see how I've written the equation next to the line. Lines that cross at a particular point are called concurrent lines. And we're used to finding the point of intersection. We can do it by graphing. The point of intersection is 5, 9. But if we do it through algebra, we're solving simultaneous equations. Now we need to learn some specific criteria for parallel and perpendicular lines. If 2 lines are parallel, then their gradients are equal. That means that m1 is equal to m2. Here's an example. Show that the lines y equals 2x take away 1 and 2x take away y plus 7 equals 0 are parallel. And you can see that these lines are written in different forms. This one is in gradient intercept form, which makes it easy for us to find the gradient, which is 2. But this one is written in general form. We need to turn this one around to put it into gradient intercept form first. Now the quick way to do this is to look for the y term and take it to the side where it's going to be positive. So it's currently negative. I'm going to add y to both sides, which will take it over the other side. I've turned the equation around at the same time. Now I have y equals 2x plus 7. The gradient is 2. So since the gradients are equal, then the two lines are parallel. Here's an example. Find the equation of a line parallel to 3x plus y plus 1 equals 0 through the point 2, negative 1. So we want to find the gradient of this line, because we're going to use it to construct our new line. So here's our line. It's in general form. We need to turn it into gradient intercept form. So we find the term in y. It's already positive, so we're going to leave it where it is and move the 3x and the 1 over the other side. Y is equal to negative 3x, take away 1. The gradient is negative 3. Here's our formula. Negative 3 is going to go in here, and the point 2, negative 1 is going to go in here and here. Substituting in, we get y take away negative 1 equals negative 3 outside of x minus 2. Let's tidy this up and expand the brackets. We get y plus 2 is equal to negative 3x plus 6. And then finally take the 2 over. Our line is y is equal to negative 3x plus 4. Now let's compare these two. Can you see they have the same gradient? So they must be parallel. If two lines are perpendicular, then their gradients multiply to give negative 1. We also say that m1 is the negative reciprocal of m2, and vice versa. So for example, if we had m1 is equal to 2/3, then m2 would be equal to negative 3/2. Here's our first example. Show that 2x take away y, take away 5 equals 0, and x plus 2y equals 6 are perpendicular lines. So just like before, we want to turn these both into gradient intercept form so we can figure out the gradients. We look for the term in y. It's negative, so let's take it over the other side, and we're going to turn it all around. Y equals 2x, take away 5. The gradient is 2. Now with this one, the y is already positive, so we'll leave it where it is. Take the x over. 2x is equal to negative x plus 6. Divide every term by 2. Y is equal to negative x on 2 plus 3. The gradient is negative 1/2. Now when I multiply those together, 2 times negative 1/2, I get negative 1. So because m1 times m2 is equal to negative 1, the lines are perpendicular. And example 2, find the equation of the line perpendicular to y equals 3x take away 5 through the point 5, 1. So here we have the line. Thankfully, it is already in gradient intercept form. The gradient is 3. So the perpendicular gradient is the negative reciprocal, which is negative 1/3. Now we want to substitute the gradient and the point into the point gradient formula. So the 1 goes in here, negative 1/3, and 5. Now you could go into gradient intercept form if you want to. I tend to go into general form when there's a fraction involved here, but that's just a personal choice. So I'm going to take the 3 over the other side, and I'll get 3y, take away 3. I've also expanded the negative through the brackets. Then go to the side where x is going to be positive, which is going to be this left-hand side. So the x comes over, x plus 3y, take away 3, take away another 5, which is negative 8. So our answer is x plus 3y, take away 8 is equal to 0. Okay, last thing for this lesson. Two quantities are said to be in direct proportion if, when one goes up, the other goes up in the same ratio. When one goes down, the other goes down in the same ratio. And this is what we write. Some quantity A is proportional to another quantity B. Now the reason that this is in this lesson is because the graph of a direct proportion relationship is a straight line, but it's a particular type of straight line. it has to go straight through the origin. So we have A is proportional to B, and that's exactly the same as A is equal to KB. We call K the constant of proportionality. Now if we compare this to our gradient intercept form, y equals mx plus b, it's very similar. But in this case, b is equal to 0 because the y-intercept is 0. And have a look at this. The gradient m, well, that's the same as k. Here's an example. The distance that a car travels is directly proportional to the amount of fuel it uses. A car travels 230 kilometers on 14 liters of fuel. By writing an equation between the distance and fuel, find the distance the car travels on 8 liters of fuel. Now you're probably saying, this is a really easy question. It's just the unitary method. I'm going to take my 230, divide by 14, times by 8. Done. But it's given us a specific method that we need to follow by writing an equation between distance and fuel. So I'm going to start by defining some variables. Let d be the distance and f be the fuel. And we're told that d is proportional to f, which means that d equals kf. Now let's find the value of k. Somewhere in the question we'll have been given a pair of values. So we substitute in 230 for d and 14 for f. And solving to find the value of k, k is equal to 16.429. Now k will have a real life meaning. In this case, it is kilometers per litre. It's a rate. So this particular car gets 16 kilometers per litre. Now that we know what k is, we have an equation. And we can use our equation to answer the question. Find the distance the car travels on 8 litres of fuel, substitute the 8 in for f. And into the calculator, the car will travel 131 kilometres. Let's finish off with a past HSC exam question. The relationship between British pounds P and Australian dollars D on a particular day is shown in the graph. Part A, write the direct variation equation relating British pounds to Australian dollars in the form P equals MD and leave M as a fraction. So they've done all the hard work for us. They've already given us the equation. All we need to do is find the value of M. We're going to substitute in these values. I'm looking at the x-axis. This is Australian dollars, so the 7 is D and the 4 is P. So let's substitute that in. We've got P is equal to MD, pounds is 4 and dollars is 7, so M is equal to 4/7. So we want to write P is equal to 4/7 D. Part B, the relationship between Japanese yen, Y, and Australian dollars, D, on the same day is given by the equation Y equals 76D. Convert 93,100 Japanese yen to British pounds. So we're going to have to go via this equation and then this one here. Alright, so starting with Y is equal to 76D. We have 93,100 Japanese yen. So 93,100 is equal to 76D. And so D is equal to 93,100 divided by 76. Just grab my calculator. I have 93,100 divided by 76 is $1,225. Now we want to substitute into our other equation. P, or pounds, is equal to 4/7 times 1225, which is equal to, times 4 divided 7 is 700. So our answer is 700 pounds. Okay, that's it for this lesson. Our next lesson is on quadratic functions.